Hello and welcome to this tphysics tutorial in which we're going to be building a Catch the Apple game. We're going to start by going to our browser. We're going to head to github.com/thebillington/tphysics. This is the repository where we have our tphysics code. So we're going to click into our tphysics.py file on here, and we're going to want to copy it as a raw file. That's going to copy all the contents of this file, which we're going to need in order to import the tphysics code. We're then going to open up idle. We're going to create a new file in idle. We're going to paste our tphysics code into it, and we're going to save it in our game directory. This needs to be called tphysics.py, otherwise we won't be able to import it in our game code. So I'm going to go ahead and save that. We don't need to worry about this anymore. This window we can forget about. We're going to create another new file, and this is where we're going to work. So we're going to save this file in the same folder as tphysics. Really important, it has to go in the same folder, and we're going to call it Apple Catch. So this is going to be our Apple Catch game. We're going to get started by importing all of our tphysics code, and actually we're going to just want, for now, let's just grab the game and the rectangle objects. We're going to start by creating a new game. So we're going to create a variable called game, and we're going to instantiate a new game object. I'm going to call it Apple Catch, and we're going to give it a background color of light blue. We're now going to create what is called our game loop. This is a infinite loop or a forever loop if you're familiar with Scratch, and inside of here we're going to have all of our game code. For now we're just going to update the game every frame. So what this does is it says whenever we call game.update, we're going to update the frame. So we're going to have some logic in here which might move our player around, might move our shapes around on screen, and then at the end of doing all of that we're going to draw a new frame and then do all the same again. We're going to do all of our physics updates, draw a frame, physics updates, draw a frame. So if we run this now, you'll see that we have a game called Apple Catch with a light blue background. So we've got a game, Apple Catch, and we said background should be light blue. We're now going to need to add a shape to the game to represent the player, and I want this to be a basket, so I'm going to make it a rectangle. I'm going to call it player. So I'm going to create a variable called player, and I'm going to instantiate a new rectangle, and you can see that rectangle is asking for x, y, which is going to be the position, width, height, which is going to be the width and the height, and a color. So I want this in the middle of the screen, so I'm going to say 0. For the y, I want it towards the bottom of the screen, so I'm going to say -200. We're going to move it to the negative y-axis. I want it to be 40 wide, 20 high, so I want it to be wider than it is tall, and we're going to give it a brown color. And now when we run this, you might think we'll see a rectangle on the screen at the bottom, but it won't appear until I've added my player shape to the game, at which point we now have a little basket. Okay. At this stage we're going to want to add in some logic, and the logic I'm going to start with is going to be key presses. So we're going to say if game.isPressed, and we're going to check for the right key press. So every frame that this runs, it's going to check if the right key is pressed, and for this frame, if the right key is pressed, we're going to take the player's X location and we're going to add 1 to it. If I run the game again now, you can see that when I press the right key, our player moves to the right. And from here you might be able to work out, if we copy and paste this, and we change this to left, and we change this to a minus, we're saying that if the right key is pressed, increase the X position. If the left key is pressed, reduce that X position. So now we should be able to move left and right. Now we're going to want to create our apples. So I'm going to create a import circle as well, and we're going to say a new variable called apple is going to be a circle. So we're going to instantiate a circle, and this is going to require an X, a Y, a radius, and a color. So what we're going to want to do is we're going to want to generate a random position. So we're going to say from random import randint. So this library called random has a lot of functions for generating random things, and we have this function random integer. Random integer takes 2 values. The first value it will be the lowest value and the second value will be the biggest value. So let's say we want to generate this apple somewhere randomly on the x position. We're going to say for its x position we're going to generate a random number between minus 250 and 250 for the x position. We want it to maybe start at the top of the screen, so we're going to say 300 for the y position. That's going to be positive on the y-axis. We're going to give it a little radius, let's say a radius of 5 for now, and we're going to make it a red apple. Okay, we're also going to add it to the game. So we're going to say game.add shape apple. And now when we run this, we should see that we get an apple generating in a random position. That first one was in the middle, but there we go. Actually, I want it to be, let's make it a little bit bigger. Let's make everything a little bit bigger. We're going to make our player a little bit larger as well. We're going to call the player 6030, and there we go. We now have the start of a shape game. Now, what we're going to want to do is we're going to want to move the apple every frame. We want it to fall. So every frame, we're going to say apple.y minus equals 3, let's call it. Should be able to see now that our apple is able to fall. At this point, we can add in our actual game mechanics, and the way we're going to do that is we're going to check every frame whether the player has collected the apple or not. So we're going to say if player.collide apple. This is just going to do a simple collision check, and it's just going to essentially say, has the player hit the apple? Have they caught the apple? Okay, and if this happens, we're going to want to regenerate the apple position. Okay, so we're going to say our apple x location, we're going to regenerate it to a new random x position. So we're going to say apple.x is going to be a new random x position between minus 250 and 250. And remember, we start the apple at 300, so we're going to say apple.y equals 300. What this should do is, when we catch the apple, oh, not fast enough to get it, let's just increase our player speed. Let's make that 2 for now. When we catch the apple, boop, now we should be able to keep on catching them. Now, let's say I'm not fast enough to get the apple and it falls off the bottom of the screen. Well, we're going to need a check-in, and this check is going to need to check if the apple's fallen off the bottom of the screen. And what we're going to do is we're going to say if that happens, we want to also generate a new position. So we already have the code here for generating a new position, so I'm just going to copy that and we're going to repeat it. We're going to say if apple.y position falls below minus 350, so if it falls below the bottom of our game window, then we're going to generate a new position for it. You should see now, if it falls off the bottom of the screen, we regenerate it. So if the player misses it, we regenerate its position. Now at this stage, what we're going to want to do is we're going to want to keep track of some sort of score. So we're going to say score equals 0. This is in our initialization code. So before we start running the game loop, we're going to set score to 0. If we catch the apple, we're going to say score, add 1 to the score. And if we miss the apple, if the score is greater than 0, we're going to take 1 from it. Actually, yeah. So maybe I should have shown you what happens otherwise. So let's start this off by just saying score minus equals 1. Okay. Now we've got the score, but we need to show the score. And the way we're going to do that is we're going to use our game.write function. I'll explain to you in a minute why this is going to be wrong. So we're going to do game.write, and we're going to choose an x position, a y position, and we're going to tell it what to write. We're going to choose a color and a font size. So I'm going to draw it at minus 250, 250, which should be the top left. We're going to say, we're going to create a formatted string. We're going to say output the score. And what this does is it takes the contents of the score variable and it inserts it into this string. So this should say score 0, score 1, whatever the value of this variable is, will get input here. And that's what this F here does. It tells me this is a formatted string, and then these parentheses here are how I tell it what to insert into the formatted string. We're also going to need a color, so we're going to say black, and we're going to need a size, we're going to say 20. So now when we play the game, you should see we have a score. it increases when I catch it, and when I miss it, our score should go down. Now at this point, watch what happens. So if it falls off the bottom, we've now gone to a negative score, which is why in here, rather than just taking one from the score, we're going to want a little check in. We're just going to say if score is greater than 0, take 1 from the score. Otherwise, if the player's already at 0, they can't lose any more points. Okay? And at this point, we have a finished catch the apple game. We could add in, some more complexity. We could increase the speed over time. So we could say if they miss, let's add in some extra variables. We're going to call it player speed equals 2. And we're going to say apple speed equals 3. And what we're going to do is we're going to replace our player speed and apple speed values with these variables. And then what we can do is every time we catch an apple, we can say player speed, add 1 to the player speed. We can say add 1 to the apple speed, like that. Which means that over time we should see that this gets faster. Yep, so it might, we might want to refine those numbers. Now the issue is that when we miss one, when it's got too hard, we might also want to take these values and set their values back. So we say if we miss the apple, then we're going to say our player speed is going to reset back to 2 and our apple speed is going to reset to 3. And what this should do is when we have caught a couple of apples and the game's getting quite hard and let's say we miss one, it should reset that score back. And actually we might want to say here, rather than score is -1, we might actually just say score equals 0. Again, this doesn't really matter. You can start to make your own decisions on how you want the scoring to work, how you want the speed of the apple and the player to work, but this is how we build a really simple catch the apple game in tphysics. Please have a look at the playlist if you want to look into any other game builds. Thank you very much for joining me today, and good luck with learning games programming.